Sorry, now it won't use my hand clicker, so I'll do this. Yeah, I'm not sure what's going on here. There we go. Okay, so back to it. Line set size. Make sure we got correct accessories for the system. Thanks everybody for your patience. On-site voltage phase match. That comes into play when we're having the three-phase on rooftop units. So we always want to confirm that we have correct voltage. Also, this correct voltage, we have been seeing a spike in residential incoming line voltage. So everybody just be aware, we have had reports of 256 line voltage. So that is something to always double check. If we have high voltage, that could be affecting our circuit boards and everything in the house also. We want to make sure that we have airflow distribution system requirements. So we want to make sure that the ductwork is in good standing order and it's sized correctly. That could be a challenge in a lot of retrofit applications. Component placement, we want to make sure there's no obstructions, there's no landscape garbage cans set right in front of the unit to affect the airflow and whatnot. We want to confirm that we have the proper controls, the refrigerant type and charge. Everything's mostly 410A right now, but we are coming to a transitional refrigerant type change, which we'll have classes in the near future on that to get you guys all ready on the A2L stuff. But this is going to come into play. You're going to have to be aware of what refrigerant we have in. Gas pipe and vent sizing, vent termination is critical. We have to make sure our system coils and filters are clean. Again, if we have an ongoing issue with a couple-year-old system, assume that that system coil's dirty and to give it a good cleaning, because the only clean coil is the coil you just cleaned. We hear a lot, well, he was just out here 6 months ago to clean the coil. Well, we don't know what he did 6 months ago. So again, the only clean coil is the coil you just cleaned. Filter, number one problem. First thing I always did when I got onto a job site is confirm that I have a clean filter. We want to make sure high and low voltage wiring is complete and secure, nice and tight. Air distribution system is sealed. Condensate drain system sloped and terminated. And then was there a gas pipe pressure test in new construction? Prior to system still line set and coil evacuation, we want to be below 500 microns. Why do we want to make sure that we're below the 500 microns? Because it assures there's no moisture in the system. So when we assure that there's no moisture in the system, once we open up the valves to the system to release the refrigerant, the only thing we want in those refrigerant lines are refrigerant and compressor lubrication oil. And always use nitrogen while brazing. I can't stress that enough because I like to show these slides, because if you do not use nitrogen, you get all this oxidation on the inside of the pipe. That's the oxygen in there burning off. When you run nitrogen through, it eliminates the oxygen, so you do not get this oxidation. And then once the refrigerant enters in here, it just cleans that clean to look like this pipe. And where's all that go? Into the strainer and the EEVs and the TXVs. And then, boom, you have faulty metering devices that you got to repair. So just, again, stress to everybody, nitrogen, when brazing, eliminates this oxidation. Startup information. This is critical. We want to know all your installed equipment model and serial numbers. You should be recording this and logging this per site. Return error and supply error sizes, along with your filter size. You got your line set size and length, vertical separation, number of 90s, and how much refrigerant was added to the system or removed. It's always good to tally that. I used to like writing that on the backside of the service panels. That way I'd write up the startup date and how long the line set was and how much refrigerant was added or removed. It saves you in the long run, whoever has to go back there. You should be recording your external pressures of the system, external static pressures of the system. We want to know if we're at a 0.7 on startup and we go back due to plugged filters or something that they covered to return. There's a couch in front of the return air grill that could be restricting airflow. We can tell that with static pressure. If we recorded it on startup in a perfect environment, we go back and it's different. What changed? You can then speak with the homeowner about what has changed. I've been in many houses where they moved furniture around and blocked off a return air, if it's down low anyway. Startup information, we want total system CFM, heat rise, and external static pressure reading. We want your outdoor dry bulb temperature. If we do have issues and you guys call in, these are all factors that we're going to ask for a detailed diagnostic. To assist you with diagnostic, we have to know this data. That's another reason why we're going over it again, because if you collect this data before you call in, it's going to help us help you diagnose faster. Heat pump AC heating and cooling startup. We're coming in the heating season. We would like you to test cooling just to make sure it works. Indoor dry bulb temperature. And that's I like gathering that indoor dry bulb temperature right there at the return air. That way it's gathering all the returns throughout the house and averaging them. Your indoor wet bulb temperature, that's going to come in play when we're doing AC cooling or charging with the piston, which I'll touch on that, and I'll show you a device that you might need to get in your service bags. Startup information. Sorry. We're going to want to know your load amperages, what the RLA should be, and then what's your actual amperage on your compressor, your outdoor fan motor, your blower motor, your strip heat, your combustion. All that tells you is you're functioning within the equipment parameters. So if we're not within equipment parameters, why? Why are we not within the parameters? So you might have to dig in a little bit deeper to find out what else is going on to prevent a failure in a month. What is your natural gas or your propane inlet and manifold pressure? Of course, when you convert it to LP, you're going to have different pressures than gas. What are your orifice sizes? It's good to notarize that. LP conversion kit. You should have if you are converting a furnace to LP, you should have that conversion sticker put on the inside of the door right near the gas valve itself. So anybody after the fact knows that you have converted that to LP. Do you have a high altitude kit? System temperature rise, which is your supply air minus your return air equals your delta T. I'll touch on what I used to like seeing in the field as far as delta T's also. Your system temperature rise and the recommended temperature rise in gas furnaces are stated on the data plate. So you can always refer to the data plate as far as the temperature rise that you want to see through the furnaces, design temperature rise, your stack temperature in your CO, your vent and gas pipe sizes. Here's a tech support quick form that we like to use and we send out to you. If you would like this, go ahead, you can just notarize in the chat line. We can email you any of these forms. We're happy to share any of these with you. This one's for the gas furnace. We do have one for the heat pumps or ACs also, but the main thing is it gives you a spot to fill out all your information right here with zoning, your humidifier, what kind of air cleaner, your size, model and serial number of all equipment. Here's a gas furnace. I know that's a lot of information, but again, it helps you because we can convert them to PDF. Just go ahead and mark it if you want some of them. I could send you all of what we have too. That way you can pick and choose whichever one works best for you and your guys. Because just looking at this, it looks like an abundance of information that could get overwhelming. But if you just take pieces to one by one, it then gets easier. And then I also use this as a learning tool. So you got a guy that doesn't know how to fill it out. First time he's going to struggle. And he's going to go through all this and it's going to take him some extra time. Second time, he's a little bit faster. Third time, he's flowing. Fourth time, he starts seeing the issue as he's filling out the worksheet. So it's also a tool for guys that don't know how to gather this information to learn how to gather the information. Therefore, it makes them a better technician when something does arise. When I was in the field, I'd save this in my little notepad on a perfectly working system on what it should be. And then if I did have an issue, I could look back on my notepad or my startup sheet going, okay, well, these are the same parameters. Why is this system not working correctly? And you feel free to give service tech services a call with all your information, and we'll help you diagnose through all the information provided. Here's the heat pump one. Also, if you're requesting job sites, we ask that you call in to tech services. I usually look to see if somebody's called in 3 times or whatnot and has submitted one of these job site quick forms. This is all the data. If you fill out all this data, we should be able to help you diagnose over the phone, right? So if you ask for a job site, we're going to send you this job site data sheet for you to fill out all the information. And we do that because hopefully we can help you resolve the issue over the phone without you having to wait another couple of weeks or longer to get us out on a job site to help you figure it out too. So it's all about taking care of the homeowner quick. So if you can get us this information, you got all your line set size, length, number of elbows. Again, nothing over 15 feet underground. We run into that sometimes, outdoor temperatures. But that's a great tool, and it's a great diagnostics resource. Heat pump AC startup. Once the refrigerant charge has been released, or annual maintenance. So this is confirmed that the indoor, and this is when a startup is, it could be the first time startup, or it could be you're going out there for an annual and you're making sure the system's running correctly. You're going to confirm indoor airflow is set to 400 CFM per ton and unrestricted. Unrestricted, I mean, if it's not new construction, or even if it's new construction, they could have a plugged filter. So make sure that the filter is clean and clear. Make sure that there's any plastic removed off of a return air grill. On initial startup, you're going to wait at least 20 minutes before recording superheat and subcool. If it's been in an idle state, the system needs to run and get that refrigerant moving through, and it takes at least 20 minutes before you can start gathering your refrigerant. So start it up and start doing something else. Your proper charging procedures depends on what type of metering device you have. Is it a fixed piston type to charge the superheat? So that's going to be AC. I guess we do have some heat pumps out there with piston too. And then know what kind of expansion device you have. Do you have a TXV or an EEV? And TXV is, it doesn't have sensors on it. Well, it has a sensing bulb. I take that back. And then the EEVs have the liquid line sensor and the gas temperature line sensor, and we're going to charge the subcooling with these devices. If charging a system with fixed metering device, I just wanted to touch on this because we do have to deal with these a lot with the pistons, and we get calls on them. You're going to charge system with a fixed metering device. So this is geared towards orifices and pistons. So charge system to superheat chart. Your typical superheat for most systems is going to be between 10 to 15 degrees Fahrenheit. You're going to need your indoor dry bulb temperature, must be between 70 and 95, because it's going to go off the cooling. Outdoor dry bulb temperature must be between 55 and 100. You have to meet those parameters to get an effective charge. If the relative humidity of the indoor system is between 20% to 70%, use dry bulb temperature when using the superheat chart. Excuse me. Thank you. Confirm which piston is needed. We do get some calls on this too. Inside the evaporator coils, you will have this chart. I pulled this out of the MXCs. And here's our piston size for 410A. You shouldn't see too much of R22. And here's the kits that you might need. There's another graph for the 2.5 ton. Your piston size need to be since system combination may not be pre-installed. So piston size needed for system combination may not be pre-installed. It does come with a variety of pistons in there, so hopefully you have the right size piston for what you need. The 3-ton, you're going to need 70, 3.5 ton is 75. Here's a superheat charging chart. This is in the install manual. You have dry bulb and wet bulb up here. So dry bulb would be your temperature probes in there. If you need to take a wet bulb, you're going to need a psychrometer. I recommend this one. This one, Gensco does carry a field piece. I carry that one around too. It makes it easy. Okay, I'll get you those fire off sheets. So what you're going to do is you're going to use this graph. Again, chart is based on 400 CFM per ton. So S9 V2s, and they come preset from factory at 350 per ton. You will have to change that to 400 CFM per ton. You will have to change that. So if you have a 75-degree return air, you're going to use this column. If you have an 80-degree outdoor, we're just going to track over 11 degrees superheat. We want that superheated vapor to be 11 degrees above saturation. So system calls for 11 degrees superheat. So if you have a 16-degree superheat, you're going to add refrigerant. You're going to get that superheat. So we're going to add some more refrigerant in there to lower that superheat. If we have lower than 11 degrees superheat, if we have 7 to 8, we're going to remove refrigerant, and that's going to raise the superheat. So that's a good slide there to kind of, because that kind of looks backwards, right? But we want to remove because the refrigerant, adding refrigerant will lower the superheat. I just wanted to touch on this real quick. Another type of piston charging chart is this guy, right? So your indoor humidity is 50%. Your indoor temperature is 85. Right here, 85. Your outdoor temperature 95. We're going to come up and intersect. We want a 16-degree superheat. So you may need, the slides aren't moving for you. What is superheat? And we were just touching on all this stuff because we only have an hour, but the superheat is the amount of heat absorbed in the evaporator. So after the refrigerant has turned into a vapor, evaporates, and before it goes to the compressor. So we're going to be turning into vapor in that evaporator, right? And it's just like water, the saturation temperature where it turns to vapor and liquid. So we want a superheated vapor coming back to the compressor before it gets to the compressor. So the amount of heat absorbed in the evaporator after the refrigerant has turned to a vapor evaporates, and before it goes to the compressor while at the same pressure. So the pressures are not changing. It's used to charge a system with a fixed metering device and used for troubleshooting refrigerant circuits. We always want to make sure that we have some superheat going back to, not too much, because then it uses the refrigerant cooling to cool the compressor. So measuring superheat, you're going to place an accurate pipe clamp thermometer onto the suction line near the suction pressure port. So in AC, you can take this suction line, you can take it right there on the middle leg of the reversing valve on heating. You measure the suction pressure and convert it to saturation temperature, which I have a slide on that next one. And then your suction line temperature minus saturation temperature equals superheat. So I just wanted to show you where that is on analog set of gauges. Most of the digital gauges will display it automatically, but on your suction side, if you had 100 PSI in the lines, that's going to register 32 degrees saturation temperature. So this 410A is in pink, R22 is in green, 404 is in red, but this pink one is what we're going to go off of. So at 100 degrees, our saturation temperature is going to be 32. If we're at 125, we'd be at 42 degrees saturation temperature. So if the section pressure was 100 psi and the actual suction line temperature was 47, that is a 15-degree superheat. So if our actual suction line temperature from our pipe clamp was 47, that would be superheated vapor. So I just wanted to show that on a regular set of gauges. If charging a system with TXV or EEV and EAC or in air conditioning, sorry, we're going to charge system to subcooling value on unit. Typical subcooling is about 10 degrees Fahrenheit, but it may vary by a couple of degrees. So always check your data plate. Your indoor dry bulb should be between 70 to 80 degrees. This is for cooling. Outdoor dry bulb temperature must be above 55 for cooling. And that's why I say always check your data plates. I mean, this is kind of what I want to see when you send in the tech services, if possible. Take a picture of the data plate. You usually see a 10-degree subcool, but not always. This one calls for 8, and some of the newer ones say plus or minus 3 degrees. So always confirm what it should be. Long line sets and vertical rise correction. So you may have to adjust your subcooling from the 8 degrees. If it was going up 30 feet and a 40-foot line set, linears, you're going to add 1 degree of subcooling. So there is a possible subcooling you might have to add. So this is a pretty easy chart, right? So this is refrigerant line lift, your vertical rise. Here's your linear footage. What is subcooling? So the subcooling is the opposite of superheat. The amount of heat expelled from the condenser after refrigerant has turned to liquid. So it's entering vapor and it's condensing into a liquid form, and before it enters the metering device. So we want liquid going to your metering device. We want the refrigerant in liquid form at the same pressure. So it's going to be changing state of refrigerant from vapor to liquid while at the same pressure. So the point below that saturation temperature is subcooling. It's used to charge a system with a thermally controlled metering device and used for troubleshooting refrigerant circuits. When you're measuring subcooling, you're going to place an accurate thermometer onto the liquid line near the liquid pressure port. Measure the liquid pressure and convert it to saturation temperature. Saturation temperature minus the liquid line temperature equals subcooling. And here again, we're going to go, say if we had 300 psi, our liquid line is right there about 96. So that's our saturation. So if the head pressure was 300, like we have here, the actual liquid line temperature was 86. So 86 would be right here. That would be a 10-degree subcool. So you're just going off of whatever our pressure is, whatever our saturation temperature with the corresponding pressure is. That's subcool. Here's pressure curves. So we're kind of getting into what we want to see in heating. We're coming into heating season. Once I was taught to use these pressure curves, because we're going to be under 55-degree air, we can actually, I've used these on other systems too. I mean, I've installed them all and fired off plenty, Lennox, Carrier, Coleman, Daikin, and I've used this graph. No other brand has these graphs with them, but these are critical to feeling comfortable about your refrigerant charge to eliminate some of the questions, right? And then the questions are what takes time. Oh, thank you, adding those quick form links. And again, important, variable speed outdoor units require the indoor unit to be configured at 400 CFM per ton. This is out of a side discharge variable speed. And it states in there, Again, it has to be at 400 CFM per ton because that's going to affect our charge. I like to put this in here too, that in the variable speeds communicating, we have to be in charging mode cooling or check charge mode heating. We have to be. So check charge mode heating is going to run that compressor at optimal speeds for the environment it's in. It's calculating outdoor temperature, indoor temperature, humidity, compressor speed, whatnot. So it's not necessarily running that compressor at 100%. That's why you got to be in check charge mode heating below 55, charging mode cooling above 55-degree outside temperature. Because it does not, you won't get a correct charge if you're just bumping that compressor up to 100%, like in traditional single stage equipment, because single stage equipment is just 100%. So with these pressure curves, you have cooling on the left side, which in cooling mode, we're going to try to achieve our 10-degree subcool, but we can also see what our pressures should be. And then we have heating on our right-hand side. So we're going in the heating season. We're going to be using our heating pressure curves on the right-hand side. Okay, here's a closer view of it. When outside temperature are below 55 degrees, we'll use the right side of the pressure curves, right? So heating, we want to be on the right-hand side. And when you're on site too, you can call in and we can go over this, review it too, just in case you want to make sure you're perfect. The three lines at the top right liquid line graph represent the indoor return temperature. Okay, so this is your liquid side. Here's our pressures. Here's our ambient temperature on the bottom. Here's our outdoor temperature is listed at the bottom. Then top line is 80-degree dry bulb inside. This represents an 80-degree return air. Our middle line is 70-degree return air. Lower line is 60-degree return air. And it stipulates that right here. And pay attention, this is dry bulb. So our regular thermometer that we can stick inside the duct. This one, you're going to have wet bulb if you want to use it in AC. So keep that in mind. This one needs a wet bulb for correct reading. So now we have an 80, a 70, and a 60-degree return air temperature. And again, I like taking that return air temperature right at the filter box, right? Because it's gathering you may have 2 to 5 returns in the house. And if you're just taking it up the upstairs one, you're not getting a correct reading. Also detecting the temperature at the return air at the unit, what's actually going into the unit. You can detect to see if there's maybe a makeup air damper that's stuck open, pulling in 30-degree air. So I do like to check that, because if it's 70 degrees inside the house and you're pulling in 50-degree air and it's 40 to 30 degrees outside, you might have some air infiltration pulling in from the outside, and then 50 degrees not going to work properly through heating season. The three lines in the lower right, suction line, so this is the suction line graph, are so close that they just form a single line. So this graph has an 80, 70, and 62 just like this, but they're so close it just forms one line. So that's why you only see a single line. So we'll go through a heating example that we will be seeing in the next month. You have an outdoor temperature of 40 degrees. So we look on the graph, we come up on 40 degrees, it is right about here. So we just go up with it. Return air temperature 65. So where does that intersect? We carry it over. We want about 340 PSI on the head pressure. So head pressure should be around 340. We go down to the suction side, 40-degree ambient. Where does it intersect with the line? Right about 85. So now we have a head pressure of 340 and a suction of 85. Your pressure is going to be plus or minus 10 of the PSI chart. So again, this is to get you close. So if you are close to these lines in heating mode, we're feeling pretty confident that we have a charge that's going to get us through heating until we can come out during springtime, summertime, when it's above 55 degrees ambient. But again, I've used this on other systems. So if you're under, you're going to add refrigerant. If you're over, you're going to remove refrigerant. Here's a single stage 5036. So this one's a 15 SEER 3-ton. So same thing, you got your discharge pressure on this side. That's where you got to get it close. It works. And the question is, does the chart change with different coil matchups? So these are out in the outdoor unit. You can see in this one's a TAM 7. This one's working with the TAM 9. So again, that's why I'm saying use these charts and get them close. This is for the outdoor unit, but the coils will change up your pressures just slightly. That's why we're just getting them close. That's why the best charging method is to get that 10 degrees subcool during a warmer climate. So you have our discharge pressures. Again, this is on a single stage 15 SEER 3-ton. We have our 80, 70, and 60 lines. 80, 70 degrees indoor, 60 degrees. And then our suction pressor has our single line. Well, this one's a little bit better illustration. You can see all 3 lines, but they're just so close that it's just using one. We're making sure our indoor unit's set for 400 CFM per ton. We have a 40-degree Fahrenheit outdoor temp and a 70-degree indoor temp. What should our best pressures be close to? Right there. So we're intersecting with that 70-degree line. We're coming up. We want about 320 head pressure on this day. Suction pressure, same thing. Follow it up, connect to the line. We want about a 93 suction pressure on this day. So with a 40 degrees outdoor temperature, a properly charged system would be about 320 PSI over 93. So again, this is to get you close, and this is to get you feeling good about the charge. And of course, this is after 20 minutes of runtime. We can go over kind of, if we got a low superheat, it's a great graph that kind of simplifies it a little bit. So if we have low superheat, if we're taking our superheat and we're at 5 degrees superheat, we have a flooded evaporator. So we're overcharged, possibly that we have too much refrigerant in there and we're flooding the evaporator, not giving it enough time. Could be a metering device issue too. If we have a high superheat, we have starved evaporator, not enough refrigerant. So the higher the superheat, we might have to add refrigerant. Low subcooling is a starved condenser. So now we're moving to the outdoor unit. We could be starving the condenser, not enough refrigerant. We got to add refrigerant if we have a low subcooling. If we have a high subcooling, say we have a 20-degree subcool in cooling, we have a flooded condenser. Going back to this, with the pressure curves, we want to get it close. And it is not published information, but we look for in heating. So in cooling, we want about a 10-degree subcool. So if you're measuring that liquid line temperature at the condenser on the outdoor unit, well, it's not condenser in heating mode, but if you're measuring that line and we want in heating, we want about a 25 to 30 degree subcool, where you have found that that's a good effective subcool. So if you're at a 40-degree subcooling in heating, it's possibly overcharged. Our pressures might be above our lines, right? So we would want to remove refrigerant, and 8 ounces seems to be a magic number when adding or removing refrigerant. The variable speed systems are a little bit more temperamental to refrigerant change. So 8 ounces is a a good amount to start with removing or adding. So again, subcooling in heating mode on our heat pumps, try to target between 25 to 30 degrees, and then get your pressures within your pressure curves. They could get tricky where you have high head pressure and low suction pressure. This could be airflow related. So that's why we're going into checking airflow static pressure too. And airflow with the TXVs also, airflow affects everything. Are there changes to subcooling when using certain Temp 6 air handlers? No, the subcooling is always based off of the outdoor unit, gauged in cooling. So in cooling, we're using the outdoor to condense that refrigerant. So that's why they want that 10-degree subcooling in cooling. There are no published subcooling for heating, but that's just something that we found. The 25-degree subcool in heating mode seems to be pretty close to where our pressures need to be. Checking airflow static pressure. Again, air is like water. It takes the path of least resistance. When measuring static pressure in the duct system, lower static means decreased resistance to airflow. Higher static means increased resistance to airflow. High static pressure restricting airflow could be your return obstructions, a filtered, plugged, or coil needs to be cleaned. Is the ductwork sized properly? We see this a lot in retrofits, the return air ductwork not being sized big enough. Keep in mind, 1-inch filters are way more restrictive than 4-inch filters. 1-inch filter doesn't have as much surface area as a 4-inch filter. So, of course, the MERV 13s and above are more restrictive than the MERV 8s. Are the filters installed properly? It's 16 by 20 should not be on a 3-ton. We still see that a lot. That leads to high restriction where it's just like a hair dryer. I tell everybody and the homeowners, I used to be out in the field. I give my homeowners the hair dryer explanation. If you buy a hair dryer brand new and you run it and you cover that backside of the hair dryer 50%, it'll still work, right? Yes, it will still work, but it will lead to premature failure. The components will die. So I hear a lot, well, this system's been installed for 2 years. I mean, it's been running like that for 2 years. Again, yes, it will run, but it will lead to premature failure, which makes everything look bad, right? So we have to get those return air and supplies sized correctly. If you have a high static filter, you're going to have to oversize that filter to get the pressure drop across it. So you might have to go to a 20 by 25 high static filter on a 3-ton gas furnace or heat pump, because you have to get that airflow. So keep that in mind. A 16 by 20 is way too small for a 3-ton, and I still see it a lot. But once I see that, we can start attacking the airflow and static pressure. Supply, obstructions, coil clean. And this obstructions, I mean, that could be the furniture. That could be somebody setting the couch on the or dog bed onto the register so it's not breathing correctly. These are all issues that are going to affect compressor life. It's going to affect compressor pressures. It's going to affect your superheat and subcool. If we do not have the correct airflow, it leads to many issues. So keep that in mind. Here's how we take our external static pressure with them. Well, in this one's Magnehelic. There's a manometer. This is a great one. This is the one I use. You're going to have to take gas pressures too. So this is a dual port where you can get the supply and the return. You're going to remove this filter if that's the case, because you don't want any filter. We want about 0.5 static. That's the design pressure of the gas furnaces and the air handlers. So in this evaporator coil, we want to be in the A, because that A coil is going to be like this. We have to be below the A coil. We can't be up here in the supply, because we want to just test our external static pressure over the furnace. We can take another reading across the coil to see what kind of pressure drop we have across that. But when taking static pressure to see if we're moving the correct amount and that we're breathing correctly, this is where we're going to take it. So if the coil was down here, downflow, you can put the probe right in the suction line, because that's above the A coil. So you wouldn't have to access the down below. You could actually put it in if you were in downflow position. I hope that makes sense. With the air handler, the coil is installed and rated inside the air handler. So in that case, we can actually go across the full air handler cabinet. With the furnace, we cannot incorporate the evaporator coil. We have to be just the furnace. So keep that in mind. With the air handler, it is tested from factory with the A coil installed. Oh, sorry, this is blower motor. A coil would be right here. Just a great illustration. And this is from fieldtechhelp.com. On my last slide, I have that written out for you guys to take a picture and write it down, because I want you to take advantage of it, and it's free for all you dealers out there, and you do not need a login, so anybody can take advantage of it. We were just talking about having some of the ISRs start watching some videos too, just to help their knowledge, right? Because it is free, and you can go through and select videos, and they have illustrations like this. This shows you the effects of low charge, airflow. Lower airflow means a colder coil, so you're below dew point. So lower airflow could lead to icing up on the coil too. No, I don't. I do plan on going through that. That is on my to-do list. I'll show you the website here in a second at the very end, when on the last slide, but I do want to go through and pick out some basic 101s. It's got basic 101 service tech, basic 102 service tech, then it has installer 101, installer 102. So you can start out with the 101s and then work your way up. There's 5-minute tutorial videos. Well, I'll finish this slide and we'll start talking about that. So lower airflow on this is one of the coils in there, right? So lower airflow could mean a colder coil below dew point. Lower airflow, lower suction pressure. Lower suction pressure equals higher compression ratio, right? Higher airflow, higher sensible capacity. Higher airflow equals higher suction pressure. And then higher airflow also improves the efficiency and lowers the compression ratio. So there's a deeper dive into that improved efficiency too. But you could just see how the airflow affects refrigerant, right? And then if we're restricted, we could be icing up the coil too. So first time, whenever I hear of an icy coil, we've got to confirm that we have the 10-degree subcooled charging, and we have to confirm that we have proper airflow. And normally it's one of those two. But again, here's the good, bad, and ugly. This is just so you can visualize static pressures. Also, this is a great slide because our good static pressure, our supply duct, here's our return, here's our supply. If we took our supply reading, it should be about 0.09 on a good. Our return air, we should be about 0.08. This one is a coil pressure drops 0.18. Filter pressure drop is a 0.12. All that total, it's just 0.47. So realistically, we want a 0.47 across the blower motor and the coil. Bad, 0.82. Bad, we can still live off of bad. We see a lot of systems about a 0.7. Our blower chart tables only go up to 0.9, so keep that in mind. Our blower CFM charts only go up to a 0.9 static. So if you take that external static pressure and we're above 1 inch water column, we have return air or possible supply air issues. And then here's ugly 1.37. On the TAM9s, we'll actually start alerting anything over 1.2. We will start getting kickbacks on high static pressure. That 1.37, again, we might work for a little bit, but we're going to be having issues when we need it the most, right? So as soon as we start dropping temperatures and we start making that system really work, that 137, it's going to cancel you out. And so when does it fail? When you need it the most, right? Deepest winter or the hottest days, that thing's going to fail on you. And it's because you're static airflow. So that has to be addressed, whether it be a bigger filter, bigger return air, adding a return air. It could be on the supply side. Homeowner has shut off a bunch of registers to save money on that side of the house. That's possible. If you got a zoning system that has one of the dampers failed, is it a Honeywell zoning system with a I can't think right now, not the backdraft damper, but the bypass damper, is this stuck open so the return air, the supply air is going right back into the return air, or should that damper be open for the relief damper, and is it working correctly? We can tell that with our static pressures, so keep that in mind. Realistically, if we get a 0.7, 0.8, we're going to let that roll, keep rolling with it, but anything above that, we got to fix it, or else you'll keep coming back to address the same issue. All right, so that's, hopefully you guys got something out of that. I know it was quick. We're having these quick hitters on November 14th. We have another 1-hour tutorial on furnace troubleshooting. So I recommend getting signed up for that one too. Jeremy's going to be covering, just going over furnace, get us ready for heating season. But we do these quick hitters. I know it's only 1 hour, but a lot of information in there that you guys can use. There's that website, fieldtechhelp.com. Write that down and use it, guys. If you have a Comfort Site login or an AS DealerNet, if you're American Standard, you can log in and you can actually keep training videos in your queue. So you can go in there and start browsing them. And as you see ones that you want to do, you enroll. So it puts it in your queue so you can go back, and then it keeps a history. So if you watch it for an hour and you got to stop, it'll keep that history. And then there's little tests in there to verify your knowledge. There's, again, 5-minute videos on how to replace the drive. There's a 5-minute spine fin repair kit. So if you have a leak in one of the spine fin coils, it shows you how to use that spine fin repair. Man, just so many great videos like those illustrations. TXV, obituary of a compressor is a good one. So you can actually learn what the airflow is doing to that outside compressor with all the breakdowns, and you can see the inside and all the working components of a compressor. Take advantage of it. Also on genscocustomer.com, we have some technical training videos posted there too, along with those forums that I was showing you earlier. We have some quick forms uploaded into genscocustomer.com under technical links, technical videos and technical links. That's all there for you guys. You can always call in the tech services, ask about it too. If you don't remember after this, just feel free to give us a call. We're here for you guys to make it easier out there installing and getting these things started up. Is there any questions? I can monitor through the chat line a little bit easier. Thanks for coming out. Sorry about the little, I'm still learning how to work all the PowerPoints and the webinars, and don't do them enough to become efficient and savvy with them. So hopefully Tyler's video or slides started changing. Is there any questions? If not, we can get to work. Yeah, there you go. Me too. Yeah, give me a heat pump any day over PowerPoints. All right. Thank you, everybody, and have a good rest of the week out there. And again, feel free to give us a call if you need us. Yeah, I'm going to go back through the chat line before I hang up and make sure I have all the emails.